Hello everyone. In today's video, I'm going to be covering over nomenclature very briefly, and I'm going to show you some new things for spectroscopy and NMR. And this should be the final component of exam 2 material, and you should be ready at this point. Um, so let's just start. So the new nomenclature is going to be knowing all the benzene derivatives and ketones, aldehydes, and just in case, I'm also going to teach you nitriles. So the ketones and aldehydes that you need to know, the benzene derivatives that you need to know are phenyl, toluene, aniline, anisole, um, styrene, acetophenone. So this is like a basic ketone on a benzene ring. You have benzaldehyde, benzoic acid. This one I've seen before: tert butyl benzene, nitrobenzene, and ethanol benzene, benzenyl sulfonic acid. Not have not seen this before, but I mean no harm in just knowing it. And so the way this works is you you would get to decide what you want as your parent, right? So you might have an OH and a CH3 and whatever else on a ring. Any of these could be the parent. But whatever one you choose to make the parent, right? You will have to designate that location where this group is as number one. Okay, so that location will always be number one. And you from there you'll decide whether you go to the left or to the right. Um, and then there's some other things as well as like orientation that that you could put. So there's you don't have to necessarily put the orientations. Like for example, you could put ortho if your groups are ortho to each other, or you could put 1, 2. I never put ortho, meta, para, stuff like that. And usually you have more than two groups sometimes. So I just put the number designation, and that's fine as well. But besides that, it's pretty much the same as any other nomenclature. You always find like the direction where you have the lowest number, and if they're the same, you alphabetically choose, make a decision, and whatever. Um, so it's pretty much the same thing. Just the only difference is choosing the right parent chain. So um, you know it doesn't matter. I don't think it matters really. What you choose, but I guess for some things like it's a very obvious choice. Like if you have a carboxylic acid on there, obviously you need to choose the carboxylic acid as the parent chain because you don't know how to name a carboxylic acid, right? Like you don't know how to name that substituent. So this would be the parent. So like the carboxylic acid would be you would use benzoic acid as the parent name instead of I think this is toluene. Yeah. You would not use toluene as a parent in this case. So just decisions like that, and obviously like nitro, you don't know how to name nitro as a substituent, so you're gonna make that the parent. You know how to name, well, I guess nitro, but whatever. I don't think it matters too much, and you can always check with the key how they make those decisions, but from what I remember, it doesn't matter. And then there's some other things like this. So um, probably the most important things are you have so if you have a benzene as a substituent, like it's coming off of something, and that's not the parent chain, right? So for example, you have a chain that has a ketone on it, that's going to be the parent. I'll show orderings and hierarchies later of these naming, but if you have a case like that and you have a benzene as a substituent, you refer to it as like, for example, 2-phenyl, wherever it's located. So it's going to be a phenyl group. So that's a lone benzene. Okay, so a benzene by itself is phenyl with YL. Don't confuse it with phenol, which is the alcohol group. And then if you have a benzene that is, you know, coming off of the parent chain and it has one carbon and then you have the benzene ring, this is referred to as a benzyl. So benzyl is the CH2 and the benzene ring together. And then I don't know what this is really. This is like benzyl bromide. Oh, benzyl bromide. I guess I don't think this is important, but the main thing is this phenyl and knowing phenyl and benzyl. Okay, So those are the main things for the benzene ring naming. And then for I think she covers naming pretty well in her notes, but just in case you guys are struggling with it. And then you have the ketones and aldehydes. All right. So for ketones, the parent name is always going to end with one, right? It's always going to end with one. So so you're always going to end with that. You're going to have like pentan one, butane one. So the E is going to be replaced with one. So butane, and E gets replaced with one. And then for aldehydes, where are you? Oh, the aldehydes are right here. For aldehydes, you're going to replace the E with Al. So this is a two carbon chain, and so it's going to be ethane is going to be ethanol. So the E is replaced with Al. Yes, and so heptane, heptanal, and so on and so forth, and not too bad. The only thing is, whenever you have an aldehyde that's coming off of a ring, right? So obviously, unlike a ketone is directly part of a ring, right? So you can call it cyclopentan 1, right? You just replace the E with 1. But in the case of a ring that has an aldehyde directly coming off of it, obviously it cannot be part of the ring itself. So what you call this is, so you have cyclohexane, and then immediately after it you put carbaldehyde. And so that's how you would name a like any ring that has a aldehyde substituent coming off of it. And so cyclohexane carbaldehyde, this is the whole parent name. And so like something that's a little bit more complicated, we have an alcohol and we have the aldehyde group, CHO. It's 1, 2. So number 1 is always where the parent group is. So 2-hydroxy, cyclopentane, and then they put the number 1 for where it is, 1-carbaldehyde. Okay? Technically, they didn't need to do that because the parent, it's implied that the parent is number 1, but this is something that I would have done as well. So number of where it is located. Okay? So that's the main nomenclature rules for this. And now when it comes to priority, right? And so this is the very nice table right here. I'm just gonna take a picture of that, right? So here you have highest acids, then esters, aldehydes. So we haven't done this other stuff yet, but we haven't done this, we haven't done this. Now we're at aldehydes, ketones, alcohols, amines, alkenes, alkynes, alkanes, ethers, and so on and so forth. You will not have amines on this exam. I'm very certain that you will not have amines on this exam, even though we do a little bit with them. Maybe, I don't know, it might be on your test. We'll see what she covers on Tuesday. But aldehydes are first, then you have ketones. And actually, what is above this is your CN group. Okay, your CN group is above this. All right, so CN, and then you have aldehydes, then you have ketones, and then alcohols, and then you have amines, then you have alkenes and alkynes, and that's pretty much it. Anyways, so I can't find the nitrile group in the book, but essentially it is the C triple bond N group. And what this refers to, if it's the parent, which it will be if it's on a chain, because it's the highest, higher than aldehydes. And so what this would be called nitrile. I hate the font again. All right, so nitrile, and if it's a substituent, it's cyano. Okay. Oh, one thing that I forgot to mention. Okay, one thing I forgot to mention. All right. So if the ketone or aldehyde are lower priority, right? If they're lower priority in the longest chain, they are referred to as oxo. Okay? They're referred to as oxo. And then when an aldehyde is a substituent, is referred to as formal. Okay, so if it's on if in parent but not highest type. Okay, so that's that rule. And then if a aldehyde is on a substituent, right? So that's that. Okay. So if the aldehyde is on a substituent, it's referred to as formal, and for all other situations, ketones and aldehydes are they're not the parent, highest priority group on a chain. They're referred to as oxo, and if I believe as well, if a ketone is on a substituent, it's oxo. Okay. So that's how you would name those things. Okay. So now let's move on from nomenclature and let's do some spectroscopy stuff. All right, so I have this picture I'm something I drew a long time ago. So what's new on the exam for you guys is the actual location on benzene rings of how things are oriented. So before you guys were responsible to understand mono and para, but now you're also responsible to understand ortho and meta. And basically over here I show how to find this out. So here you have trisub. So if you obviously have three groups on a benzene ring, it's going to be 3H. If para, it's going to be 2H, 2H, and it's doublet, doublet. It's meta and ortho, they look strange, and it's going to also be 4H, but it's going to be hard to figure out from the NMR exactly whether it's meta or ortho. And so from here I have in the parentheses check IR. And so when you go to check IR, you're going to look in the fingerprint region, okay? This is on those keys and these are on the keys on the back where like the NMR spec keys where it gives you the values. But basically, if you go to the 700 to 800-ish region, okay, you'll have these peaks that are there. And mono and meta both, all you need to do is look at the number of the peaks. So mono and meta have these two peaks that are together like this. Okay? So mono and meta have two peaks, and this is how you would differentiate. So meta, like mono, will have two peaks. And then ortho and para both are singular peaks. So basically all you have to do is, if you're confused whether it's meta or ortho, it's definitely, and it's not para and it's not mono, then it's either meta or ortho. All you have to do is look at the 700 to 800 region and see whether you have two or one peaks. So if you have two peaks, then you have meta. And then, that's your orientation. If you have one peak, then you have ortho, and that's your orientation. And that's basically all that is new. Aside from that, what you should have known, you have aldehydes, and that's the 910 region. Okay? And benzene rings, alkenes, this is stuff that you guys should know already. And then one tip that I, want to emphasize again, C13 NMR, the most useful thing for it is to determine whether or not you have an ester or not. And if you have an ester, C13 NMR will tell you, and you'll find it in between the 160 and 180 region. That's where you'll find the ester. And if you have a peak there, that means you have an ester. So if you're confused, this is a very good check, and it can make the difference between getting the right and wrong structures. Aside from that, I think that's everything, and I wish you guys the best of luck and to hopefully study hard and prepare for this exam. All right, see ya.